All right, thank you so much. So welcome everybody. I'm really excited to introduce our great panel for you today. I will start with Eric Gregory is here from Emory University. Eric has been with Emory for 15 years. He serves as the Assistant Director of Engineering Services, Commissioning, and Building Automation. He actually started their ongoing commissioning program at Emory in 2011. So yeah, that was over 10 years ago, called the Sustainable Performance Program. Really glad you're here, Eric. Going on down the line of our owners, we have Leslie Kramer and Michael Hong here from Stanford University. Leslie is the Associate Director of Energy Retrofit Programs at Stanford, and in her 10 years there, she's managed programs for the Facilities Energy Management Department that focus on improving energy efficiency of campus buildings. In 2017, Stanford launched the Integrated Controls and Analytics Program, or ICAP, and as part of that effort, Leslie helped develop cost-effective approaches to retrocommissioning and ongoing commissioning. So also from Stanford is Michael Huang. He manages the newly formed ongoing commissioning program at Stanford. And as part of the utilities department, he also works to ensure campus buildings are returning optimal hot and chill water return temperatures to the heat recovery chillers that replaced steam cogen in 2014. So welcome, Michael. And last but not least, we have a few owners here, but we also included a master systems integrator. And for those of you that don't know what that is, you will by the end of this session. So we have Jason Whipple here from IBIS. Jason has over 20 years experience with CRE systems engineering and managing smart buildings for Fortune Global 500 companies. Jason has worked on designing and building multidiscipline integrated ecosystems as a small business owner and from within a global multi-billion-dollar corporations. Currently, in his role at IBIS, his focus is business development and using his experience and creativity to create solutions for high expectations clients. Aren't we all high expectation clients, Jason? All right. So we just wanted to kind of give a start of our ongoing commissioning. Here's the AIA quality assurance, and I'll let you have a few moments to read through that. The description, I won't read this, but we'll just let you take a moment to that. But we really want to focus on implementation and contracting and the different means to get to an ongoing commissioning project or process. Our 4 learning objectives today, the first, we're going to discuss how different owners procure and manage ongoing commissioning services. We're going to talk a little bit about differences between contracting some of that work in-house within an owner's organization and then also relying on service providers. Thirdly, we're going to look at how some master system integrators are helping clients select product and project delivery. And then finally, looking really at this ongoing commissioning multidisciplinary team that may include a systems integrator or technology provider to really maximize the value of ongoing commissioning. This is a BCA kind of rounding on terminology, which we refer to new construction commissioning, existing building commissioning, and then we're here to talk about ongoing commissioning, that final phase in a building life cycle. Our definition of ongoing commissioning, and this comes from the BCA, that I thought was a good place to start, is the means and process of investigation, evaluation, monitoring, and implementation of improvement measures related to facility performance on a continuous basis to maintain the built infrastructure to the performance standards of the current facility requirements. All right, so with that, we'll get to our first question. And this is over to you, Eric, at Emory. You were the driving force behind launching Emory's ongoing commissioning program, the Sustainable Performance Program in 2011. And then, as I understand it, after 4 years of implementing that process, utilizing your building automation system, you created an RFP. Can you describe that procurement process, successes, and lessons learned?
Yeah, so I got the program off the ground in 2012 with $75,000 in kind of a proof of concept investment. And with that, we used about 2/3 of that investment, and were able to identify 79 issues. Of those 79, we were able to do a pretty easy calculation on about half of those, and figured out we saved with that $224,000. So that was proof positive. So I had a FTE, full-time employee position approved, and got him hired in 2013. So early on, just to give you some background, our AFDD was homegrown rules that we wrote in code, panel by panel, system by system. And as we got smarter, we realized that, then we would have to double back panel by panel, system by system to incorporate, our better ideas. So we realized scaling was going to be hard. So in 2015, we wrote an RFP and awarded our FDD vendor. And primarily what that got us, as far as the ability to scale goes, is the platform assigns equipment to a rule versus the other way around, where we were doing, assigning rules to equipment. And if that makes sense. And a little bit about our contract. Early on, it was strictly just the annual software fees. But now we're up to 30 buildings in our SPP. 24 are in our fault detection platform. So now we are contracting our vendor to help us manage all these insights. So we've estimated that a single ongoing commissioning engineer can handle roughly 2 million square feet of non-lab space and roughly 1 million square feet of lab space, and we're up to almost 5 million square feet. So now we have our vendor helping us until we can get another ongoing commissioning agent on board.
Thank you, Eric. For a slightly different perspective, Leslie, I know that your program has come up through a few different models, even at the same time. Can you tell us about 2 methods that you've used to procure and manage ongoing commissioning services, and a little bit why you have more than one model?
Sure. And I think there's a slide in the slide deck as well that I could start with. If you go to the next one, that'll be a good place to start. And we'll go back to this version because I wanted to start with the second slide 9. One more. There you go. So our ongoing commissioning services are managed by an in-house team, but Stanford has used 2 different models for deployment of fault detection and diagnostics. The first model uses a leading cloud-based FDD provider, KGS Clockworks, and KGS is responsible for onboarding buildings to their Clockworks platform using data from our DDC system. The software, as you may be aware of those types of tools, uses built-in algorithms that KGS developed to identify HVAC malfunctions. And the dashboard that service provides a lot of other useful information, including estimated avoided energy costs of repairing faults. And so in both of our models, we have an ongoing OCX program manager who currently is Michael, who's here on the call. That he's responsible for managing funding, prioritize buildings for ongoing commissioning, and coordinating with the FDD platform manager and what we're calling the Scrum team. That's a cross-disciplinary team that looks at the faults that have been detected and decides what to do about it. We also have this example where we're using a cloud-based service like KGS. That's Clockworks. In the second example, I'll talk about how we're doing that in-house. We have an MSI that's internal to Stanford. We call it our Facility Automation, FAC, Facility Automation and Controls team. So, and then I mentioned the Scrum team earlier. So that's sort of the first thing we did, and you were asking about how we got where we were, but we initially interviewed multiple providers of FDD and piloted one, and then ended up settling on Clockworks as the best one for us, and we piloted that one. And then we also had a second model that we've been using as well, and partially that's because the energy consultants that we work with on our retrofit projects and new commissioning projects had been using SkySpark. And so that was the way we were introduced to that fault detection and diagnostics tool. And we realized that we could also take on and consider doing this, bringing this in-house. So our MSI worked with our energy consultants to help us get set up to use SkySpark internally for multiple purposes, our retrofit projects, our new construction, and also now for ongoing commissioning. So let's see, then in the second model, if you go to the slide right before this, I'm showing the model we're using with the in-house FDD platform, where the responsibilities shift a little bit. We still have the same Scrum team. We still have Michael as the ongoing program manager, but instead of relying on KGS as the main way to get faults identified, we're using SkySpark instead. We've determined that that's a better option for buildings that are on the main campus, especially because they're all managed by our in-house MSI. But we're also still using, you asked about why we're using both. We're still using KGS Clockworks for buildings in auxiliary departments, such as the School of Medicine and the athletics department, that aren't managed directly by FAC or the MSI, because we're relying on the vendor to do the integration with the control systems in those other departments. But where our MSI is in-house, we can use them. We've figured out how to integrate SkySpark into the workflow. So that's an example. There are two approaches that we've used where it's a similar structure but different FDD tools in the two examples. I think that's it.
Great. And I thought you could just walk us through the cost effective and how all these players kind of made the business case for ongoing commissioning.
Yes, thanks. I forgot the slides here too. Yes, thank you. Well, what we did is we went back and looked at fiscal year 21 to see, was this cost effective to use this mix of FDD tools, using some consultant time, using our own staff. And we looked at the results we've gotten for it was only a half dozen or so really potent ongoing commissioning measures in the first year that generated a lot of savings. And when we look back at the cost and benefit, we were able to build a case for it being cost effective. And so we're continuing to improve our method of evaluating the program. But because like a lot of in-house operations, it's sometimes difficult to separate out the cost of things that are just maintaining our building systems versus what's being used specifically for ongoing commissioning. But nonetheless, we did our best and we're able to document that it's cost effective, and we're going to continue to do that going forward. And we have new methods now for calculating energy savings and for accounting for costs so that we can get even more accurate picture going forward. And this other part here just shows that I mentioned that we settled on, when we first started ongoing commissioning, we were kind of we were calling it retro commissioning, and we had multiple teams working in different buildings. And what we ended up concluding was more cost effective to have one cross-discipline team. It's part-time work for everybody, where the team meets couple times a week for these Scrum type sprints, and we move one building a month through the Scrum team rather than having multiple teams working on different projects. And this has turned out to be a more cost-effective and efficient way to work. So that was it.
Great. Thanks, Leslie. Kind of shifting back over to you, Eric, you mentioned, being able to take on staff that are dedicated to your ongoing commissioning program. Do you work with commissioning providers as well, and kind of how do you balance, like, what's the best fit for what type of commissioning work?
Our SPP, we have one dedicated ongoing commissioning specialist, we call him, and we have two dedicated commissioning specialists, and their focus is correcting the insights that the ongoing commissioning specialist gets. We also have three dedicated specialists that do our new construction commissioning in-house. On our larger projects that we cannot handle, I do hire third-party commissioning consultants as an extension of our group. And as far as our integration to SPP goes, at the end of the project, I require them in their scopes to assist us and help us develop rules that are, non-standard rules that are unique to the facilities. And a little bit about just the benefits for Emory, why we keep commissioning in-house. All that facility or project knowledge, we keep it in-house, and which then enables us to support our operations staff, as they're getting familiar and coming up to speed. And then, and then we can speak to the design functional intent that operations rarely get, to help them understand why systems are designed, the way they were.
Absolutely. You speak to some of the challenges in turnover, which is definitely a value add for any commissioning process. So now I just kind of want to shift a little bit and bring Jason into the conversation. I guess, Jason, what is your role, and how do you typically work with your clients? And is it, are you typically working with the owner on a platform, or do you work on single projects?
Let me start for a little bit based on your initial comment when we started, is what is an MSI, which is a question that comes up quite frequently. In short, a master systems integrator is different than a systems integrator, because a master systems integrator is typically at the ownership level and more integrated into things like ID departments, smart infrastructure, APIs into non-facility or non-OT systems, space reservation systems, all sorts of tangential systems that can benefit the facility operations. What we do is bring all those systems into something like a unified user interface or a ownership database, or data lake, which we can talk about in a bit. But so our role can be all over the place. Commonly, we master systems integrators are just consultants at the ownership level to get kicked off with an OCX program for new construction or existing. Or it can be all the way to the level where we are providing the technology, providing the energy analysis, all of the services, providing the FDD software to a full comprehensive rollout to a smart building systems. And it's all just a contract to a master systems integrator. And a master systems integrator may then subcontract a systems integrator or a controls contractor or electrician or all sorts of different subcontractors. So that is the principal role that we play.
So when is a system integrator or a master system integrator necessary? Where do you see that being able to add value or even the missing link on a project.
Yeah, absolutely. So this is where our slide, there you go, kind of helps. So typically there are specific use cases where an MSI needs to be involved. One of them is the universal user interface, bringing things in, like I mentioned, space reservation systems, advanced lighting systems, advanced sequence-based on lighting systems, shutting down zones when there is nobody in the room. Sounds very simplistic, but at an MSI level, integrated PV systems, solar systems, all sorts of systems, they kind of too many to mention, to be honest. But we take those all in at various technologies and unify them into one user interface so that there is no distinction between one system or another, despite whether it's an OT or IT or something other kind of technology. The other aspect that we are typically brought in is when there is a data lake, a organization-owned data lake. This requires a lot of database expertise, and so it goes beyond your typical SI or controls contractor knowledge base. And so we will get into various different kinds of databases and consult with an ownership on what technology to use, or sometimes they already have an idea, and so we're responsible for getting data into that database, translating it from your typical OT system into a more traditional database technology. So we're doing that, and that's certainly something you'd want an MSI for, because it's a very holistic kind of data set, or feature set, excuse me. Also, data accessibility, that really kind of rolls into that API connection or some other kind of high technology connection that's outside of the OT world, or even in the OT world, can help. And then if you would please advance to the next slide. And then quickly, also one of the things MSI is very integral to is custom solutions. So if there's a very specific use case where a client wants something that's kind of out of the box, a MSI is someone who's going to do actual coding for you, whether that be in HTML5 or in C++, or at that programming level beyond what your typical SI or controls contractor would typically do. And then, of course, IT-OT convergence, I mentioned that, bringing your IT and OT together, and smart infrastructure, smart buildings, smart risers, and then also bringing in that entire campus ecosystem, which I kind of touched on a little bit before. But also I want to mention lifecycle change management kind of consulting we're pretty heavy into as well, because we're involved at the ownership level. We're more interested in that holistic lifecycle beyond just a commissioning effort or beyond a construction. We are more involved in the lifelong project layout of the NOI and making sure that that's effective for the client.
Thanks, Jason. That's a really good overview. I'm going to kind of pivot back to Michael. For your cloud-based SDD program, where Stanford contracted directly, what was your role of your in-house facilities automation center? We've heard from Jason, and some of these expertise in integration and data transfer is done by these third-party consultants, and I wondered if you could kind of walk us through what your facilities automation center, what their role was on your program.
Sure. So our FAC created the network and the framework for the communication to Clockworks, and with that, there were a couple different iterations for how we actually got data in, and then they had to tweak what the security limits for how much data could be queried and at what rate and time of day so that our system isn't overloaded. So ultimately, we were able to pull data from SkySpark, using that as a database, and we successfully demonstrated that our haystack tag points can be seamlessly integrated with third-party cloud-based platforms like Clockworks. And that, as a short summary, but it took many iterations of okay, this data is dropped here. Well, and then we have a drop there, and then figuring out at what point the connection broke or where it froze. So we went all the way from connecting straight to the JACEs in the building to higher level of just pulling everything out of SkySpark. So FAC was responsible for making sure the data was flowing and the points were mapped correctly so we could have a good baseline for OCX.
That's a wonderful resource to have in your facility. I know I come from a much smaller facility, and I think that's not, it's not common for the smaller institutions to
right.
have that. Great. So just kind of moving on, I'm going to put this one to you, Eric. How do you balance operational fault detection with kind of the energy side, and how do you does one take priority when you have limited resources?
I think I have a pretty short answer for this one, but we've set up weekly reports that tell us how long an insight has been triggered, or one of our rules has been triggered. And so we focus on those, and we take the top insights from those reports. Because at Emory, most of our energy spend is in our lab buildings, so we do focus on those insights, versus we give them a higher ranking, than an academic building, just because it provides us with greater energy savings. Yep, that's the gist of it. Told you it'd be short.
Okay. Michael or Leslie, do one of you want to take a stab at that one?
Yeah, I'll also take a stab at that. I was just going to mention that our energy consultants have worked with us to create a dashboard in SkySpark that ranks the relative impacts of sparks related to energy, comfort, safety, using a scale of 1 to 5. And then when we bring that list to our Scrum team, they review the data and they collaborate, check in with each other on how to prioritize the top opportunities to prioritize. And at least at Stanford, each member of the Scrum team has access to different funding sources, because someone will be there from building management, someone from energy. And so if an issue has an energy savings benefit, that funding will come from the energy funds. And if the benefit's primarily safety or comfort, then it comes out of a reactive maintenance budget. So we try our best to balance the impacts that way and to collaborate on how to prioritize opportunities, because we spend a lot of time spending time thinking about that too.
Yeah, and another thing we'll try and do is, should we just fund everything out of reactive maintenance up front, and then after the sprint is complete, then do energy calculations or to contribute energy utility funds as a rebate afterwards? So we've kind of gone back and forth on should our energy program fund some up front that we know are a slam dunk, or do we want to do the calculations to verify them and then transfer rebate funds? So kind of hemming and hawing still, trying different options.
So you both kind of talked about your process a little bit in terms of reviewing, and we're calling them different things, right? So from Eric, I'm hearing you say insights. There's sparks, right? If we're talking about SkySpark, and different names for the things that are coming out of the fault detection. To even get there. As Michael, can you talk to us a little bit about your data normalization program and your data management that kind of underlies how to scale up the fault detection that you work that feeds your ongoing commissioning process?
Yeah. So if you don't have good data, then you can't have good analytics, right? And when we first kicked off our OCX program, we saw our dashboard and said, oh, wow, this is great. You know, there's all these opportunities and we're going to save $100,000 a year. And then when we started going through the individual opportunities, we found that a lot of them were false positives. It could either be the data was mismapped. For example, the return air temperature was actually flagged as mixed air temperature, or a VAV box shows a airflow 10 times higher than it's rated for. So then the energy savings is calculated as huge. But then if you go in the field, you see that one of the differential pressure sensors that measures airflow at the box was disconnected. So then it's reading at this giant differential. So although there are savings and there's maintenance issues, it's not this big golden egg that we initially thought. So the tool is still working, and we kind of need to weigh the pros and cons of when it's working well and when it's not. So yeah, kind of navigating, making sure everything's mapped right, and given its somewhat black box analytics, that it's taking all the right inputs. And
I'd also add that we worked hard in the last year on developing a standardization in terms of a tagging library and a rules library that, in terms of data normalization, I think that's the term people are using. I'm not sure exactly what that means, but if that means sort of standardizing some of the ways we're tagging and setting up rules for our technology, that's one thing that we've done. Also, Stanford as a campus is standardizing around the Niagara N4 platform for our DDC systems. So that's sort of the baseline that we have to have. We're not able to do this. Our ongoing commissioning program as it's designed right now doesn't work very well outside of the buildings that are all upgraded to our latest DDC standard, because that's relying on haystack tagging and tags that are related to the Niagara system to some extent.
Yeah,
that's another aspect of normalization.
Before some buildings are fully on Niagara N4, the zones, all the conference rooms, offices, etc., those are DDC full to the zone on Niagara, but then the air handlers are controlled by Delta V. So then if you're trying to look at a VAV box fault, often you need to reference the air handler as well, and it might not be in SkySpark or whatever FDD tool we're using because it's in different systems. So
that's a good point also. Yeah, and actually good point that we don't need a building to be on N4 technically. It's just so that the tagging gives us some ability to normalize it.
Yeah, it makes it a lot smoother, yeah.
It sounds like you mean have some integration involved, right, to bring some data sources from different systems. And I wanted to key off something, Michael, that you said. So you mentioned going in the field and verifying, a tube on a DP sensor was disconnected. So are you saying that a part of this process you have to go into the field?
Yes, definitely, because a lot of things will look great on the screen, and then you go in the field and, you just remove one ceiling tile, and all of a sudden it all makes sense. Whereas you could spend hours looking at the trends, like, what? How could this valve be open but not, no cooling is happening? Oh, because someone zip tied the actuator on and then it snapped, something like that. So we try to curate a list of opportunities that need field verification before we take action on them. And then once a technician is out there and verifies, yes, this damper isn't stroking when I'm, controlling it to the DDC, then we say, okay, let's move forward and take action on this one.
Absolutely. And I think we have some questions coming in that are related to this next question that I wanted to pose to you, Eric. You used the phrase FDD of the FDD Can you talk about that? And then I'm going to bring in a question we're getting from the audience of how often are you calibrating the instrumentation that is being pulled in that is being used on the analytics?
Yeah, so going back to what Michael said earlier, being sure that our insights are true and we're not chasing false positives, is very important because you can waste a lot of time chasing false positives, and there's many reasons why. But in our weekly reports I talked about earlier, a large drop in insights from one week to the next doesn't always mean we've done our jobs well. It often means something's broken, whether that be a comm link or just a failed device that handles our trend logs that goes to our FDD platform. So we call it our FDD on our FDD to make sure our data is still working. And so we've got rules both on the FDD platform side, that clue us in when there's a lack of trends received. And then we have some rules on the BAS side that, tell us when our panel's not communicating. But at the end of the day, it's also very important just to maintain good records. And oftentimes, we find issues just because of our records.
Mm-hmm. And what about the actual instrumentation in the field? Do you have a calibration frequency that you're looking at, or part of another process that kind of does any type of point to point on the end devices?
We're struggling with that. We're trying to do better, but we do try to focus on particular inputs, our airflow monitoring stations that are controlling to our outside air quantities. Those as they get dirty will read lower, so you'll have more ventilation air than you think you have. So in Georgia, that's a main energy conservation measures to keep those calibrated. We do keep all of our revenue meters calibrated on a frequent basis. But that's about the extent of it at Emory. I bet Stanford has a more sophisticated program.
Kind of as needed. Go ahead, Michael. I cut.
Okay. Yeah. Well, typically, if the data makes sense and it's within expected range, I'll go back to the VDD box example. If the airflow that the DP sensor is reading is within the design range, then it's likely it's fine enough. Airflow is hard enough to measure already, right? So it's just kind of weighing what's good enough, and yeah.
And I was going to mention that some people are looking at ongoing commissioning as a component of a preventive maintenance program, so that you would, instead of going out and checking every sensor, obviously that's too costly, but we are using fault detection sometimes to find a sensor that's out of range and that's no good. So maybe it's an alternative to regular calibration, is to have a good program that flags a sensor that's out of whack.
So there's one question that I want to get to before we kind of transition to our closing. And Jason, feel free to take this in the direction that you think most appropriate. You kind of mentioned a unified user interface. Can you tell us a little bit more about that and in the context of maybe where you're seeing it being used in an ongoing commissioning program?
Yeah, and in fact, I'll probably dovetail it into kind of my answer to the previous question as well, is, you know, when we're seeing things like false positives and doing that analysis portion of the rules of the FDD rules that are triggering that we find, what we found is that it's parts of a story, right? Like a rule trigger is not the end and the beginning. It is merely a piece to the whole puzzle. So we tend to combine that with things like energy analysis, metering, and then also, you know, a user interface, you know, our user interface that we use, our unified user interface, can actually rewind through time. So what we'll do is we'll combine those rules along with energy or other items we're seeing, operational schedules, and obviously all sorts of things that are going on. And we will rewind our graphic to that time and see what is happening. So essentially, what we're talking about is using a unified user interface to Sherlock Holmes what is going on, to figure out what is causing that false positive. Sometimes we find false negatives through this methodology as well, which is worse than a false positive because you're leaving money on the table, sometimes a lot. So it is part and parcel to getting things done with ongoing commissioning, because I think what happens a lot is people look at ongoing commissioning as just a technology, and it's not. It's a combination of technology and people. People have to be part of the solution. It can't be just, hey, we're going to contract this platform and it's done. It doesn't work like that. It is a very intensive tool and knowledge set and analysis of someone who knows what they're doing, knows how a building works, but also knows how the rules work. So it's a strong union of both of those to get something accomplished.
And I think, you know, I've heard a lot today that resonates, right, from, you know, Emory talking about the design intent and having commissioning specialists that one of the reasons being in-house is because they know the buildings and what they're supposed to deliver, and being able to interpret those rules and deploy the resources. And I just, you know, as we kind of wrap up here, I thought we'd go around and think about, from a commissioning provider's vantage point, which many on the call here are from, you know, what would be your one piece of advice, either from kind of lessons learned or maybe someone new to the field that wanted to embark on providing ongoing commissioning services, maybe to a new owner, maybe an existing client. You know, what's a pitfall to avoid, or your one golden nugget? And if anyone wants to go first, chime in, or I'll choose.
I have two. I jumped ahead. Sorry, Eric.
Go ahead,
I have
Jason.
two. One is getting buy-in at the highest, most level is, to me, the number one path to success. If you're not getting a buy-in from an executive level or someone who's signing those checks, it's not going to go very far, because it is heavy investment, it's heavy time, and no matter how you look at it, it needs a commitment at the highest level to see it through, because ongoing commissioning is a ongoing process, right? So it's not a CapEx one-time done. It's a budget, operational budget, and that's hard to get commitment in sometimes. My second one is properly evaluating the technology in play. As an MSI, what we find is a lot of times the technology has been chosen before we arrive. And so we'll see systems that, for example, only push data up to a cloud, and the high subscription costs, inaccessible data, all sorts of issues with amazing technology, but it just makes integration difficult, not impossible, but just very difficult and expensive and costly, and those subscription costs can add up and take out of your OCX budget. So to me, technology evaluation, starting with consultants early and starting at the top, are my one and number two path to success.
Eric, you want to go ahead?
Yep, thanks. What was I going to say? I've gotten away from using the term warranty phase when I'm writing a commissioning scope of work for a third party. I call it optimization phase. Occupied optimization phase. And so I'm really writing a lot of third-party scope in there, that keeps those guys around longer and really helps us to flesh out, the issues and really, optimizes the building to its occupied state. I think historically, at least when I was a commissioning agent, we did functional acceptance testing, to a design parameter. And then, we called it a day, and then we went on to the next job. But on the owner's side, I really see the importance of really being around and helping us through that that occupancy period. And if you can incorporate FDD, into that, would be fantastic. And I know you have to decide, is that, something you bring to the owner as a part of your scope, or is it does the owner have a program, and then you can incorporate that and use that as part of your acceptance testing and your optimization services.
I was going to throw in my one thought to leave people with is that people probably aren't starting from scratch with ongoing commissioning, and probably have already done some work in the past with energy upgrades, retro-commissioning, and have some good partners. So what we were able to do is leverage some of those existing partnerships with really, especially, good energy consultants who have a lot of knowledge as well about these tools and our buildings. And we were really able to leverage their expertise as well. We have an in-house energy engineer that we wouldn't have gotten where we were without relying on some of our existing partners to help us get forward.
Absolutely. Michael, do you want to round us out?
Yeah, sure. At Stanford, when we were trying to push OCX from a energy efficiency initiative, we got some resistance because the shops and the technicians have long backlogs already, and if you market it as just energy efficiency, then they might, get value engineered out, just like a lot of things in design projects, right? So we took the approach of, if a building is operating well, then by design it'll be energy efficient. So taking that angle helped us get more traction at the executive level, like what Jason was referring to. And then, vet the providers. If it seems too good to be true, it probably is, because at the end of the day, you still need to give them all the data. They won't come in and magically fix all your systems. So, just be realistic with what your internal team can provide and what the provider is telling you that they can give you.
Thanks, Michael. I think we have a few minutes for some more questions. And TJ, I don't know if you want to give everyone the directions for the Q&A.
Yep, and as just a quick reminder, text chat is located on the right-hand side of your screen. To submit a question, type your question in the small text box at the bottom, and when finished, click the send button. Please note that due to time constraints, our panel may not be able to respond to all questions submitted. Back to you, Janelle.
All right. So we have any advice for evaluating building analytics bids received from an RFP? Maybe Eric, can I put that one to you?
Yeah, let's see. I was prepared for that question above that one, but let me advise evaluating building analytics bids. Let's see. It's all about best fit with your organization. and kind of back to what Jason was talking about, is it's not just software. You've got to have a team that's going to address the insights. Otherwise, it's you're not gaining anything. So it has a lot to do with how much personnel can go and attack the insights, and also how much owner capability do you want to have in modifying rules? As you learn your building, and you might want to tweak some rules in different zones and different systems that are unique.
Absolutely. There's another question here about the Department of Energy's EMIS specification and procurement support materials. I would say that is definitely a resource that can be pointed to. I don't think any of our owners on this panel, except for me, have used it. But there is some good documents there, some example RFPs from different owners that have been scrubbed, and even some rubrics for evaluating proposals against your kind of priorities that are available there. And that's also referenced by the ongoing commissioning chapter of the commissioning handbook that's put out by the BCA and reviewed by LB&L. So that is a good call out, and we can include the link to that as well. So we have a few more minutes. I would, Stephanie asks, what is the benefit of SDD solutions like SkySpark versus setting up similar rules directly in the building automation system?
I can chime in on this one. Similarly to Eric, we've done a little bit of both as well, and we find that the rules that you can set in the BAS are pretty limited and kind of simple by nature, which is good, right? You don't want it too complicated in there. But for us, we couldn't do much beyond send us a flag when the return temperature is below a certain number, or send a flag if this damper goes above this position. And that's helpful, but what we really like about SkySpark, where it can pull in multiple data points and kind of draw a larger picture for us, it'll tell us, it looks like your preheat coil isn't actually opening up because your supply air temperature is not heating up or whatever. So what's nice about SkySpark and other tools is it can aggregate different points and then draw a bigger picture, whereas if you're doing it directly to the BAS, you're more limited and might just be getting a small zoomed in snapshot. And a lot of BASs don't have great graphics and display, and it could just be kind of clunky to track down faults.
And I've got a few comments on that as well, because I alluded to that's how we started. And I kind of equate a BAS similar to our human brains. We only use a small percentage of our capacity of our brains, and it's kind of the same with how we use our BASs. So yeah, you can most definitely make them smarter. But like I said earlier, it was a scaling issue with us, and being able to assign equipment to a rule versus assigning a rule to the equipment. But that being said, we still use rules within our BASs, and I've been fortunate to have some really sharp guys who are real familiar with our Siemens BAS that we have primarily on campus, and so they have a lot of code that feeds up into a trend lock. So it does a lot of analytics inside the BAS, and then it feeds up into a trend log, and then from that we've built some different insights in our FTD software.
So I think this is the final question to Jason. We got a question, as a master system integrator, how do you deal with latency and SDD?
Yeah, I hope I understand this question correctly, but so one of the things I mentioned earlier is our ability to rewind our graphics through time, so we can watch, a air handler or a VAV go through its operations during the period of the FDD. So that's particularly how we handle it, which is why we have an emphasis on that. Is you can identify the causes of issues on many occasions, being able to do that. If the question has more to do with just data quality, I think from a latency standpoint, that has to do with your data integration, your database data flow, in keeping those timestamps accurate all the way from the data flow from the end device all the way to a data lake collection point, which could be the other way that question could be construed. So I hope I answered both versions.
Yeah, and I'll also note that hearing from Stanford and Emory, the faults that are coming out of these analytics as part of this ongoing commissioning process are typically not acted upon in hours. If I got that right, like I hear it being acted on, a weekly report, a monthly sprint. So maybe the latency of a few hours, or maybe an overnight refresh to the data lake. I don't know what that is, but it sounds something about right. May not be as important when
we're not using them for alarms. Yeah, we're not using them as alarms.
Yeah, it's rare to act upon an FDD rule immediately because of what we mentioned, those false positives, and just because a rule gets triggered on a VAB doesn't necessarily mean it's not an air handler problem, right? It's depending on how many are triggered. So there could be all sorts of things you don't want to jump to conclusions. You want to do some analysis. And that's kind of what FDD is about. It's identifying deeper issues over what a simple alarm could trigger you. So it's kind of trying to give you some clues. So you certainly won't want to immediately act on it. It's something that needs some analysis.
Sure. Well, thank you all so much. I think we're at the top of the hour. Just want to thank all of our panelists for giving us some of their time. And to our audience, I would encourage you, if you have any other questions, we can take those offline. And we really appreciate your time. In the slide deck that will be provided, there's also contact information for all of our panelists as well, and also some other resources from the BCxA and otherwise on ongoing commissioning.
Thank you, Janelle and panel. We really appreciate your time and expertise. On behalf of BCxA, I would like to thank everyone for your participation in today's event, Ongoing Commissioning, Contracting for Implementation. The BCxA is a registered provider with the American Institute of Architects Continuing Education Systems, and credits are available for this webinar. When I end this webinar, your computer will be redirected to a brief post-event survey. Please take a moment to complete this survey, as it will help us better meet your training needs. This concludes today's program. Thank you for joining us, and have a great day.